Okay, this podcast is going to talk you through how to calculate KEQ, for the equilibrium lab. So our equation again is Fe plus 3 plus SCN in equilibrium with the FeSCN complex ion. So the K expression would be the concentration of FeSCN over the concentration of Fe plus 3 times the concentration of SCN minus. Now these concentrations that we are referring to are going to be equilibrium concentrations. So if you go back to the previous problem in the post lab where you had to calculate the equilibrium concentrations of iron, SCN, and FeSCN, those are the values we'll be using here. So for test tube 1, and in the previous podcast I demonstrate how to solve for these values, but in test tube 1, my equilibrium concentration of the FeSCN complex ion was 2.88 times 10 to the negative fifth, and I found my equilibrium concentrations of iron 3 to be 5.71 times 10 to the negative fourth, and my concentration for SCN was 3.71 times 10 to the negative fourth, and if I were to solve that out, I get 136. Now, you have several test tubes with varying beginning concentrations, but you have to remember that the K value for this equation at this temperature, and we will assume that the temperature was constant throughout the lab, unless you did it on 2 separate days, in which case that could be a source of error, but K for this reaction at the same temperature should be the same regardless of what the beginning concentrations were. So when you calculate K for each of your test tubes, it should be the same number. Now it probably won't be, but you need to calculate K and find the average of all your values, and then in your discussion of error you will talk about was K the same throughout, and if it was not, why was it not? And so that would be, I would expect that to be included in the discussion of errors.